Okay, in this video we're going to talk about arithmetic progressions. So in an arithmetic progression, it's important to understand that the terms, so each consecutive terms of an arithmetic sequence, increase by the addition of a fixed amount or decrease by the subtraction of a fixed amount. So basically we have to be adding or subtracting the same amount each time to have an arithmetic sequence. And if we've identified it as an arithmetic sequence, then we have three formulas that we're going to be using. So the first formula we're going to look at is this one right here. And you'll see that this is U sub n, and then over here we have S sub n, and S stands for sum. Okay, but in both of these formulas, A is going to represent our first term. So it's very important to understand what each thing represents. Also, these formulas are on your reference sheet, so you don't have to memorize them. So A is our first term. N represents the number of terms that we have, or the number of terms that we're going to go to in the sequence. And that's often referred to as the nth term. So the 7th term or the 12th term. Okay, that would be N. D is our common difference. Now we call it common difference, but we might be adding, we might be subtracting, okay? And the way you find your common difference, if you have some decimals or some numbers that are a little bit more challenging, you're going to do any term minus the previous term. So you can take any term that you have in the sequence and subtract the term before it, and that gives you your common difference. Okay, and then on this side, our U sub n is going to be the value, and that's important. So the value of the nth term. So if we say, what is the 7th term? If the 7th term is 21, then 21 is the value of the 7th term. So you've got to be careful not to get n and U sub n confused, okay? And then over here, S sub n represents the sum of n terms. So if we wanted to find the sum of 10 terms, then n would be 10, but the S sub n would represent the sum of all 10 terms. And then you see that in this formula, so basically we have two sum formulas. We can use this part for our sum, or we can use this part for our sum. And I will tell you that this one on the right here, this longer one, is used for us way more often, because in this case you have to know what the last term is to use this first part, or you have to be able to find the last term. And so L, when we have it, represents the last term. But you have to be very careful to not assume you have L and to know that you have L. So we're going to look at some examples. And arithmetic sequences are all about identifying what information you have and then just picking a correct formula and plugging in. Okay? So let's look at our first example. Our first example says find the 17th term of the arithmetic progression that starts 12 and then 9 and then 6. So let's identify what we know. We know A is 12 because that's our first term. We can find D. Remember, D is always one term minus that before it. So we can do 9 minus 12 is going to be equal to -3. And so that's what D is. You could have also done 6 minus 3. So we know that D is negative in this case, which means we're subtracting to get to the next value. And you can see that here because it's decreasing. Okay. What else do we know? It says find the 17th term. So we know that n equals 17. And so we're not told to find the sum. We're not given a sum. There's no information about a sum in this problem. So we are not going to use our sum formula. We are going to go to this formula here that I gave you on the last page. Okay, and so let's just start plugging in and see what we know. We don't know U sub n. We're supposed to find the 17th term, which means find the value of the 17th term. And then A was 12. In this case, N was 17. And D was -3. And so actually you can see on the right side here, we have no missing values. We have no variables. So you can just type this whole thing right here in your calculator, or you can do it by hand, do that math very carefully, and you're going to get that U sub n, and actually I can write here U sub 17 because that's what we were trying to find. U sub 17 is equal to -36. So what that tells us is that the 17th term is -36. If we kept going down and we had 17 terms, we would get to negative 36. Okay? Okay, let's look at another example. This one actually asks us how many terms. So they're asking us to find how many terms. They didn't give it to us, and so n in this case is unknown. We don't know what n is. But we're asked how many terms are there in the sequence 11, 15, 19, and then we would keep going until we got to 643. Okay, so A is 11. It's a good idea to always identify what you have. D in this case would be 15 minus 11 or 19 minus 15. Okay, and in that case we're going to get 4, that D is 4. And you can see that that's a positive, and we are increasing. 11 to 15, I have to add 4. 15 to 19, I have to add 4. So that's my common difference. Okay, and again, just so you can see it here, because it is on your reference sheet, you need to go to your reference sheet and find these formulas so you know where they are. This is the formula that we have of u sub n. And I'm not really considering my sum formula because in no way in this question does it state sum or ask for the sum or even have a plus sign or anything. So we're going to use this formula again. We're going to say u sub n equals, and in this case, A is 11, N we didn't know, and we know that D is 4. So I'm missing an N, and right now I'm missing a u sub n. So we need to go back to our question and figure out what do we know. We know we don't know N. Okay, but in this case it says how many terms are there in the sequence, and it shows us that we're going to be ending with this term. So that's the value of u sub n, and we need to know how many terms we needed to get there. So I can actually put that in place of my u sub n. So just be careful about the difference between n and u sub n. Okay, and now we can solve this, and you have some options algebraically. What do you want to do first? I'm not going to spend a lot of time on the math because algebraically we should be okay with that. So review that if need be. I'm going to distribute this 4, which is going to give me 4n minus 4. When I combine like terms on my right side, I am going to get 7 plus 4n. And then of course I'm going to subtract 7 from both sides, which is going to give me 636 is equal to 4n, and when I divide by 4, I'm going to get 159. So it took 159 terms to get to a value of 643. Okay, let's look at this next example. It says find the value, again, find the value of 8 plus 6 plus 4 plus, and then we keep going to get here. So that addition there, and it's telling us to add all the terms. So we're actually finding the value of if we were going to add all of these terms together and stop at the negative 32. So because there's plus there and because we're asked for the value, we do need to consider our sum formula. And so you had 2 of them. That was S sub n is equal to, you had 1/2 n times a plus L, and you had 1/2 n times 2a plus n minus 1 times d. Okay, so let's look at this for a second. So in this case, we know that a is 8. We can figure out that d is going to be 6 minus 8, which is going to be negative 2. And because they're asking us to stop here, to find the sum from 8 to this point, from our first term to this point, we actually know that our last term is negative 32. So I can use this in this case. The problem that I have, and let's look at that. So if I start plugging in, I don't know S sub n. I don't know what the sum is. I'm trying to find that value. But I do know, actually I don't know n. It didn't tell me how many terms was here, so let's leave n. What we know is that a is 8 and that L was negative 32. So when you do this, actually we have a problem on this one because I have too many missing values. I want this value, but I need to know n to get to that. And even if you tried to use this one over here, we know A and we know D, but we are still missing n. So either one of these right now is going to be a problem. So sometimes we have to go back to our other formula and use it to first find something that we might be missing. So notice in this formula now, I know that A is 8. I know that n is what I'm trying to find, so we're going to leave n. And I know that d is negative 2. And that this u sub n, so if I'm trying to figure out n to get here, then this is my nth term. This is the value that I'm trying to find, but I need to know what n, how many terms it took me to get there. But this would be u sub n. the value of u sub n would be negative 32. So I'm going to plug in a negative 32 there. And so I can actually use this to solve for n. If I do that, I'm going to distribute this negative 2. I get negative 2n plus 2. This is going to give me negative 32 equals 10 minus 2n. And when I move my 10 to the other side, I get negative 42 equals negative 2n. And so in this case, n is going to equal 21. It would take me 21 terms to get here. And so now that I know that, I can go take that and I can find the sum of the first 21 terms, which is actually what we're being asked in this case. So that's going to be 1/2, and I'm going to plug 21 into n, and then I have 8 plus negative 32, which is minus 32. And since this is all numerical values, there's no variables, you can actually plug that whole thing into a calculator and find that value. And that value is going to be negative 252. The sum of 21 terms is negative 252. And it would work the same if you had used this formula. After you found n, you could plug into that formula and you would get the same value. Okay, so on this one, we are asked for the sum. It explicitly says find the sum of the first 100 terms. So that's telling me the first 100 terms is that n is 100. But now you see there's a lot of fractions going on. So what I suggest to you in a problem like this is to rewrite these as 1/5, 3/2, and this one is going to be 7/4. And this way, we know that A is 1, that was obvious, but D is going to be, and you can do this as either one. You can do 5/4 minus 1 or 3/2 minus 5/4. But if I do 5/4 minus 1, I'm going to get 1/4. So that's my value of D. Okay, and so let's see, what do we need? If we're doing sum and we're doing the sum formula, you can see that this is ... I do not have a term over here, so I definitely do not know the value of my last term. So I have to resort to my longer formula, 1/2 n times the 2a plus n minus 1 times d. And then you just got to start plugging in what you know. So I'm trying to find the sum of 100 terms. So my n is 100. I do know that A is 1, so I'm going to put that 1 in there where that A is. Again, n is 100, so we plugged that in here. And D is 1/4. Okay, so now on this right side, there is no variables. You could, if you were very good with your calculator and you were very careful, you could plug this whole thing in and get a value of S of 100. Or you can do it in little stages. You could do the inside of this and then multiply it by this outside. It's up to you. Again, I'm not going to spend time on the algebra because that's a skill that we should have at this point. If you need help with that, you need to let me know. So my value is going to be 137.5 and when I do that math. Okay, so that's my sum of 100 terms. And that makes sense because we had fractions here, so I do have a decimal here, or a fraction, either way. Okay, in this example, where we have an arithmetic progression, we are given the first 3 terms and the last term, so it does give us the last term, and we are asked to find the number of terms. So what that's telling us again is n is what we don't know. You guys can see that A is going to be 3x, that's my first term. In this case, be very careful. Even though there's an x there, that's just part of my sequence, there's an x in every term. So D is going to be 7x minus 3x, second term minus the first, or 11x minus 7x. And when I do that, I'm actually going to get 4x. So that's my D. And since we're not asked about a sum, we're not given a sum, there's no sum involved, we're going to go straight to this formula. And so we are trying to find the number of terms to get here. And since this is our last term, or this is the value of our term, that's actually u sub n. And we need to know how many terms it took to get there. So we're going to put 43x in place of n. And a was 3x. And n is what we're trying to find, so that's going to stay in. And then D was 4x. And so in this, guys, I just need you to be really careful because the x's are not what we're interested in. What we're trying to solve for is that n right there. Okay, that's all we care about. Leave the x's, solve for n. So you have some options as to how you want to do this. You can distribute the 4x first. I'm going to actually move this 3x. by subtraction. And when I do that, that's going to give me a 40x is equal to n minus 1 times 4x. And because this is multiplication here, instead of distributing that 4x, which does work, that's a valid method, I'm actually going to divide by the 4x. And so 40x divided by 4x, notices the x's will cancel, and I'm going to get 10 is equal to n minus 1. I can add my 1 to both sides, and I get n equals 11. It took me 11 terms to get to 43x. Okay? All right, go back and review what you need to, and I will see you in class.